Good morning, all. So, hope previous class you all able to understand how to perform the linear regression operation in the data set given, right? So, let me share my. So, in the previous class, if we have seen, means I got some error when I'm trying to plot the graph, right? That is not any mistake in the code. That is because I have not installed the matplotlib library properly. Okay, that is why I got the error, but I have solved it, and after that only I have uploaded the code. If you have checked the code means you might have seen. So this is how you will be getting the output. So all the blue lines are nothing but the scatter plot of the actual value, and the red line, the red dots are nothing but the linear line which we have created using our linear regression algorithm. Okay, see it is creating on slope like a line. Okay, this is how it will be creating. Okay, okay. So in today's class, we are going to see about a new another one project, another one algorithm we are going to see. Okay, and the project name is advertisement sales prediction from an existing customer. Okay, here in this particular project, based on the existing customer in the sense who has already purchased the product, who has purchased, who have not purchased, based on that one data has been collected. Okay, from the data using, so here what algorithm I am going to use today is logistic regression algorithm. Okay, so one by one we will see about the algorithm and steps to be followed. Then we will see the coding part. Okay, so first step, the finding the problem application. Okay, what is the problem statement here? So we need to predict whether the new customer who will buy the product or not. So that is going to be our prediction statement. So second step, collecting the data set. So what are all the data we need to collect from the user? So for this prediction, we need to collect users age and then salary. Okay, so age and salary is going to be the input. Okay, and output is going to be the purchase status. Purchase status means whether the person has bought the product based on the ad or not bought the product. Okay, so we will be using 0 and 1. If I say 0 means he will uh, not purchase the product. If I say 1 means yes, purchase the product. Okay, then so load and summarize the data set. So for loading purpose, we will use the pandas, right? Dot it, this data type. This data set is also going to be in CSV file format only. So to check the number of rows and columns, like we will be giving the dataset panda.read CSV, load the data set, and then shape. It will give rows and columns, and then we will see the sample of that particular data set. Okay, to display the first 5 rows in our data set, we will be using dataset.head. Okay, then in the next step, what we will do, segregating the data set into X and Y. Okay, so here from this particular input and output, which will be our X and which will be our Y? So X is going to be my input, right? So I will be taking both age and salary column as my X, which is an independent variable. Okay, there are different names for this. Okay, we will be saying as input or variable. Okay, or we can also call them as we can call them as independent variable, or another name for it is feature. Each column is considered as a feature. So using that feature only, we will be predicting the output. So X is going to be my age and salary, and Y is going to be my purchase status. Okay. So that is my X and Y value. Again, we have already seen the syntax, right? Using the ilog, if I give colon, comma, again colon minus 1 means it will leave the last column, and then remaining column will be taken as X. Dot values if I give means it will be converted into series. Okay, if I didn't give dot values means it will be taken as data frame with the column names also. Okay, that is the difference between giving a dot values and not giving dot values. Okay, and Y is equal to dataset dot ilog, only minus 1. If I give colon comma minus 1 means only the last column I am going to take it as my Y values. Okay, then in my fifth step, splitting the data set to train and test. So for that we have learned, right? Can anyone say from which module we have imported this train and test method? sklearn dot, remember or not? No, from the sklearn dot, then which class we have used to take the train test split function? Correct. Model underscore selection. Okay, from the model underscore selection only, we are having the train test split method. Okay, so in that we will be passing the X and Y value, and then test size again it is given like 25 percentage. As I told, we can give 20 to 30 percentage for the testing purpose, and then random state. So random state here also given 0. You can give any specific value. Like in the previous example, I have given 12. Okay, if you want means you can go with 0 also. Okay. Then after giving splitting the data into training and testing part, next what we have to do? Feature scaling we have to do. Okay, I have not yet showed you the data set. Okay, let me show the data set. Or without showing itself, I am asking you whether for this particular data set we need to do feature scaling or not. We are having two column in the input. One is age, another one is salary. Okay, in the linear regression, we had only one column which is number of hours a student has studied, right? For lab purpose, I have given one data set. Have anyone seen? In that, I have given two columns. One column is how many hours the student has studied. Second column is how many hours a student has slept. Right? Hours. Yes, hours I have given. So both are having same unit. That's why we didn't do any feature scaling, right? But in this case, we are having two column. One is age, another one is salary. Whether both are having same unit or different unit. Both are having different units, right? Age means it will be mentioned in years. Salary means it will be mentioned in rupees or in dollars. Anything it can be mentioned, right? For our assumption, it is in rupees, like that you assume. Okay, it can be in thousands, lakhs, anything it can vary, right? So obviously we need to do feature scaling for the particular data set which we are taking today. Okay, and we have already seen what type of problem we will be facing if we are not using feature scaling, and feature scaling is the only solution to solve that particular problem. After performing feature scaling, this is how our data set will be looking like, and we are having two different types of feature scaling. One is standardization and another one is normalization. So if you are going for normalization means we will be getting output between 0 to 1, and if we are going for the standardization means we'll be getting values from 0 to infinity. Even negative values also we can get, minus infinity to positive infinity. Then in the seventh step, we are going to see about the algorithm. Previously, we have seen the linear regression. So now we are going to see about the logistic regression algorithm. Okay, so logistic regression means value will be ranging between 0 to 1 only. Either in our case, it will be either 0 or 1 only. Okay, this S curve we are saying, but it doesn't mean always first value should be 0 and later values should be 1. 0 means the person has bought the product. Sorry, 0 means the person has not purchased the product. 1 means the person has purchased the product. Okay, previous data. Like that, we will pass on new data. Means we will pass the new age and a new salary, and we will ask to our algorithm whether this person with this age and salary will buy this product or not. It will reply yes, he will buy, or he will not buy this product. Okay, it is a rough assumption only. It doesn't mean you will not buy that product or buy this product. Has to buy. It is a prediction. Okay, this age, this salary is there means possibility is high of buying this particular product. Okay, so if it is saying like the person will buy means we can market them, right? We can make them to buy. Okay, because the chances are more. If it is saying the person will not buy that particular product means the chances are less the person will buy, so that we don't need to put lot of effort on that particular customer. Okay, that is the reason for going for this type of prediction. Okay, so then we will go for the training part. So in the training our model for pre-processed data set, which is the X train, Y train we have taken, right? That we will pass to our fit method. We will pass model dot fit X train value, and then the Y train value we will pass. Then validation. So how we will validate? We will predict the value, right? Or we can use the confusion matrix to check what is the actual value and what is the predicted value. Both we will compare, and then we will perform the confusion matrix, and we will get some accuracy score for that. Finally, prediction. Okay, so observe how our model is classifying our new data. So if I'm passing any new data, it can be a test data, or manually also I can pass some data. Okay, and we will pass into model.predict. Using model.predict method, here if you see means I have given sc dot transform new customer, like that I have given, right? So why I have done given like this means, here we are performing feature scaling for the training data, right? Now, without converting that new data into feature scale data, if you are passing means again you will be getting wrong output. Feature scaling, why we are going? Because age and salary are having different units, right? When getting the new data from the user, we will be getting as it is only, right? Age, if I ask means you will giving the age value 24, 26, like that you will give. Salary also 1 lakh, 10 lakh, like that you will be giving. Directly we cannot go and predict the value. We have to convert those new values also feature scaled value. That is why I have given like sc dot transform, that we will see how we will be using in our program directly. Okay, then finally, okay, prediction we will perform, and we will check whether it is predicting correctly or not. Okay, this is what we are going to do in today's class. So any doubt is there in the steps part? No, isn't it? So we will directly go to the programming part, then we will be able to understand it even more clearly. Yes. Yes, we can give the new data or we can give the testing data. We are split it into two halves, right? 20%, 25% is kept, right? That is what completely new data only for our algorithm, right? We can use that also. Testing data. We can test the data, or we can create some loop, sorry, condition formatting. We can, if some prediction has been made and we are getting output as 0, then the person will not buy. If the person will buy means if else statement we can do. That also I will show you how we can create. Okay. So hope my screen is visible. So this is my data set. My data set name is digital ad underscore dataset.csv file. Okay. So here age is there, salary is there. As I mentioned, status also is there. Okay, status will be either 0 or 1. So 0 means the person uh, with the age of 18 and salary of 82,000 has not purchased the product. Okay, that is what it means. Then if you see here means a person with age of 29 and a salary of 80,000, he also not purchased. But in the third case, if you see means person with the age of 47 but only with a salary of 25,000, he has purchased the product. Okay, so it will be varying. We cannot understand the pattern, but our program, our algorithm will try to understand the pattern from this. Okay, for that only we are going to train our model. Okay, so as we know, first step is importing the libraries. So I'm just importing the basic library, NumPy and Pandas. So Pandas as PD. NumPy optionally we will be needing, but still I'm just giving this. So NumPy and Pandas has been imported. Then I have to load the data set. So data set is equal to PD dot read underscore CSV. So digital same that file name I have given. Since the file name is present in the same directory, if I give like di and if I'm giving tab also, it will be auto completed. Okay, otherwise cap small you need to be careful with when you are giving the file name. Otherwise what it will do, it will return the specified such file does not exist in this particular directory. Like that the error it will throw. Okay, then summarize my data set. So for summarizing purpose, simply we have seen two things, right? Data set dot shape. So if I give data set shape means I'm having 400 rows and 3 columns. Okay, so let me uh, check few datas in my data set. So data set dot head. So you can give head dot tail, that is up to you. So if I don't specify also, I will get 5 rows. So here you can see it clearly. Okay, 0 and 1 is there. Okay, then as a next step, we have to segregate the data set into X. We can call it as input or independent variable. Okay, so for segregation purpose, what syntax we have seen? So X equal to, otherwise I will use capital X, capital Y. X is equal to data set dot ilog, okay, colon, comma, again colon minus 1. So it will leave the last column alone and remaining column values it will take as X value. So I will check the X value. So this is my X value. Only age and salary has been taken. Okay. Similarly, I am going to take the Y value also. So Y is equal to dataset dot ilog colon comma minus 1 dot values. See, once if you are doing it repeatedly means you will remember, start remembering the syntax. Okay, only if you are practicing only you will able to remember all those syntax. Okay, see all the Y data 0101 everything has been taken. Okay, then we have to split the data set into train and testing part. So for that, already I have asked that question, right? From sklearn dot model selection, we will be taking the train test split function. So I will just typing from sklearn dot model selection, import the train test split function. Okay, so we can give like sorry, x train comma y train. See, order also important. First x train, then x test, y train, and then y test. So y is equal to train test split. So I'm passing the x and y value. Okay. Test size, I'm giving it as 0.25. Okay. And then random state, I'm giving it as 0 as mentioned in the mind map. Okay. Now, okay. Hmm. Any number you can give. See, if you are giving random state means each time when splitting the data set, it will split in the same order. Okay. If you are not giving the random state means every time it will randomly take the 80 percentage, or here I have given 25 percentage for testing, right? So 75 percentage it will take randomly. It will not be in order. Each time it is changing means our output and accuracy also will be changing every time, right? The splitting will be same set of splitting will be there. Previously what it has splitted 75 percentage, that will be splitted this time also. Even if I'm giving 0, right? Even if you are typing your code in your system and giving 0 means for you also same splitting will happen. So that what accuracy I am getting, you can also get the same accuracy. Okay, that is the thing. But if you are changing the test size means then accuracy also possibility changes is there. Okay, 90 percentage you are giving for training, only 10 percentage you are giving for testing. Random state you have given 1 2 3 positive numbers only, no negative numbers, positive numbers only you have to give. You can give 0 to any numbers. Okay, based on that it will split the data. Okay, understood why we are giving the random state. Test sites is mandatory. We have to give how much we are going for testing purpose. A random state is optional. If you are not giving means each time your accuracy will be changed and you cannot re-get, I mean get the same accuracy again. That is the problem. Suddenly you got 90 percentage accuracy or 95 percentage accuracy, but you don't know how the splitting has happened, right? How it has splitted the data, you will not know. Again, you cannot recreate the same splitting, right? So that is the reason we are specifying random state. Okay. Same set of rows, same values will be repeated. Any number we can give. Okay, that is not a problem. Positive number, any number you can give from 0 to any number. Okay. Then, so splitting part over. So up to here we have seen in the previous class also, right? In the linear regression also up to here we have done. But in the linear regression I have removed the feature scaling because same unit I have used. But here we know that the column is having different units. See, number itself, see, it is having 18, 29, 47. Maximum how much age will be there? 100. Not even 100 a customer will not have. But if you see the salary means minimum itself you will be having 10,000, right? Starting from 10,000 to 1 lakh or 10 lakh also per month a customer can gain. Okay, so what will happen is our model will give more priority to the salary column rather than the age column. So to avoid that only we are going for the feature scaling. Here we will be using two methods. One we called as fit transform and another one we called as transform. So fit transform means this method will calculate the mean and variance of each of the feature. Each of the feature means each column it will separately find the mean and variance present in our data set and that will be replaced in each value. Whereas if you are giving transform means transform method will transforming all the features using the respective mean and variance. Understood the difference? In fit transform, each column separately will be taken and for that mean and variance will be found and each column will value will be replaced. Whereas in transform, all the values will be taken equally and then for that it will perform the mean and variance, and each value will be replaced for all the values. Okay, that is the difference between fit transform and normal transform. Okay, then where we will give fit transform and where we will give transform is for training purpose we have to give it separately, separate column, separate features should have separate feature scaling. For testing purpose we can mix all the values together, we can mix and we can perform mean and variance for each and every value, because the value which we are getting in the real time may not be perfect all the time, right? So that is why we are doing this type of transform in testing data. But for training we should give proper training, right? Then only it can predict properly. So that is why we give fit underscore transform for training data. Okay, you can note it down somewhere. Okay, fit transform is for training purpose. One way, I mean, transform is for testing purpose. So for that, so here we are performing pre-processing. Okay, this process is nothing but pre-processing. Okay, so from, okay, newly I am importing this also, you just note it down from sklearn dot pre-processing. The class name itself we call it as pre-processing. Okay, sklearn dot pre-processing. In that, as I have told, we are having two things, right? Standardization and normalization. I am going to use standardization. So standard scalar method I am going to use. So standard scalar S caps and then S, both the S are caps. Standard S caps and then scalar S caps. Okay, so for this I am going to create one object. Okay, I'm giving short name as SC. Okay, SC is equal to standard scalar. Okay, one object has been created. So in this SC object only we are having the fit transform and then the transform method. Okay, here first letter is not caps. Okay, the actual T and F are small only. Okay, so after transforming, I am going to change the original data itself. So to change that, X train is there, right? So X train is equal to, previously if I check the X train value, okay, let me show that also. So X train value is like this only, right? Age and salary is there. Similarly, test also will be, remaining values will be there. Okay, out of 400, this is the 25% of the data. Okay, sorry, just a minute. Now I'm going to change it. So for changing purpose, I will give like sc dot fit underscore transform. Okay, we are having actually three methods. Simply we can give fit also. In previous model, if you have checked, simple linear regression model dot fit only we have given, right? That is for training purpose. Here we are not giving training, we are transforming the data. See here, I have given stud dot fit only, right? That is for training purpose. Here, pre-processing purpose, I am giving fit transform. Okay, and then I will pass the xtrain value. Okay, and then similarly for xtest also, sc dot only transform I am going to give, and then I will pass the xtest value. So now if I go and check my xtrain and xtest value means, just so xtrain value, see, xtrain value has been converted. to standard scaling. Okay, so it will be starting from minus infinity to plus infinity, values can be changed, but mostly it will be yes, normalization. Here we have used standardization, that is why I have given standard scalar. Normalization means another name for normalization is min max scalar method. Okay, that method I have not used. If you are going to use means min max scalar you have to give. Okay, that is completely up to us only. In case you want the output column should be ranging from 0 to 1 only. Okay, that case specifically you want between 0 to 1 means we can go for min max scalar method. Otherwise no problem, any values not a problem for me means we will be standardly going for standard scalar method. Okay, so standardization I have used C and D. I think spelling mistake. Okay, correct only, right? Standardization method. Okay, similarly why testing also I have changed, because while testing time you have to use this value only. Okay, then we have to train our model. Okay, testing part over. Now I'm going for the training part. Up to here any doubts is there, anyone? Okay, so let us go to the training part. Okay, for linear regression, how we have imported the linear regression, can anyone put it in the chat? sklearn dot, what class we have used, class name. Why pre-processing? That is what I am saying from the beginning, Amlan. Pre-processing we are doing. Why? Because one column is age. It is having different unit. Another column is having salary, which is having different unit. Okay, as a human we know this is the age, so these values will be always less and salary is going to be always high. But for our machine learning everything is a number. It does not know, okay, salary, that is why they have given higher value, age, that is why they have given lesser value, like that and all. It will not take higher values there means higher priority it will give. So if it is giving higher priority to only salary column means our data will be biased. Okay, the output which we are getting will be biased. So to avoid that only, we are putting everything in a common standard. Okay. After converting into the common standard, we have to train our model with the new data which we got. Yes, from sklearn dot linear underscore model. Okay, not linear model, linear underscore model. So here also I am going to use the same thing. In the linear model only we are having the logistic regression also. Okay, so from sklearn dot linear underscore model import, this time I will be importing the logistic regression. Okay, so logistic regression I am going to import. So for that I have to create one object. So I'm just giving model. Any name you can give. So for easy understanding syntax purpose, I'm giving it as model. So model is equal to, so logistic regression. So inside that, here also I can pass the random state. Previously where I have passed the random state, I have passed the random state in splitting the data, right? Train test split. So in the regression, the algorithm also we are having random state. Okay, that also we can specify. So here I'm specifying. If you're not specifying also, it will not throw any error. Okay, that is an optional column only. Otherwise, simply I will just show in the help session. Let me check. Otherwise, wait. Let me run this. Okay. See here itself, they have clearly given the class logistic regression in model sklearn dot linear model is there. Okay. So from here, if you have seen the syntax, let me check. See here also we are having the random state. It should be integer value. That also I forgot. I have told positive value, but it should be also in integer value. Okay, that I have not mentioned you. It should not be in floating point value. Okay. So by default it will be none. Okay, default none means it will not have any value. So randomly it will be taking each time. So to avoid that we have to specify some value. Okay. Hmm. No, not necessary. See here I haven't given the random state. So it will take none as my random state. Okay, you are asking like whether there I have given random state equal to 0. Here also I have to give random state equal to 0. No, same set of values only, right? Train and split what I have splitted. For example, to make you easily understand, assume that I have splitted the data, like only the odd rows alone I have taken. What where I have done in the training splitting part itself I have done. Here in the logistic regression algorithm is training, right? During the time of training, it will train from the different order. Same data only, it will not train in the same order. That is the difference. Okay, first value if this like for example. Um, Understood, right? What I am trying to say. Yes, randomly, but it will train all the values. Only order changes. See here, first value is 27,96,000 is there, but in the algorithm, while testing, first it will take 32, age 32 and 18, 1,80,000. So based on that, next value may be changing. That is the only thing. Okay. So without giving the random state, I am giving this, and after giving random state, I will check how our value is changing. Okay. So I didn't give any random state here. Okay. I'm just commenting it also. I have run this particular line. I have not yet fitted the model. Fit means train the model. I have just created an object for this particular class. After that, what I have to do? I have to fit my, sorry. So model dot fit x train and then y train. Okay. So let me run this. Now, so training has been completed. Now, what I can do is I can predict whether the new customer with the age and salary will buy this product or not. So before going to that, first I will pass the testing data and I will check, okay, whether the person will buy this product or not. How much accuracy we are getting from this particular model. Then I will perform this particular operation by passing new values into my model. Okay, so to predict all the values, okay, based on the testing value, I want to perform the prediction. So for that, I will be creating one new variable called y predict. Okay, is equal to model dot predict, and I will be passing the x test value. Okay, so after testing, I will check the predicted value. See, this is my predicted output. Okay, and what is my actual output? Y test, right? So this is my actual output. So here if you see means starting I'm having 4%, it is showing like buy mean they will buy. So but here if you see means first two customer will not buy. Like that our model is saying. Okay. So we have to find the accuracy, how much accurate our data is. So for that I'm going for the confusion matrix. Okay. So I can use the confusion matrix and then the accuracy score. Two things I can use. So where I have taken this confusion matrix function and then accuracy score, can anyone say sklearn dot which from which class I have taken the confusion matrix? In previous example I have used R2 score. Here I am using the accuracy score. Okay, nothing big difference. Sklearn dot correct. Sklearn dot matrix. So from that class only we have taken the confusion matrix. So from the same class I'm going to import the confusion matrix as well as the accuracy score. Okay. So to find the confusion matrix, simply I'm just giving Cm is equal to directly also you can find. I'm just storing the value. So confusion matrix I have to pass y test, which is the actual value, and then y predict, which is predicted value of my our model. So simply print confusion matrix comma Cm. Okay. So if I run this means, so this is my confusion matrix. So here if you see means I have told right where the value should be high, always the value should be high in this two area only, because the first value represent true positive and the 19 represent the true negative. Okay, and we are having no any false negative, and we are having like 20 data out of entire data. 20 data is having false positive. Okay, false positive means the value is false but it is showing like true, like that changes will be there. Okay, so we will find the accuracy score. Using the accuracy score we can find how much percentage our data set is uh, accurate. Okay, we can directly also find that by using the formula. Formula is nothing but here I have given right accuracy score TP plus TN by TP plus TN plus FP plus FN, which means all four values. So if I do that confusion matrix based on the value like 61 plus 19, right? TP and TN divided by all four values. So 61 plus 0, so no need to add. So 20 plus 19. Okay, so what value I will get? 0.8. So 0.8 means 80% accuracy I will be getting if I'm trying with new data. Okay, so this calculation will be performed by our accuracy score function itself. No need to manually calculate it. So for that, so I will be using, okay, wait, AS like the accuracy. Okay, accuracy score is equal to accuracy score of y test, comma, y predict. Okay, while printing, what I will do is, so accuracy of the model which I have created is, um, okay, what I can do. F string. I'm just converting into F string. So inside that, I will pass the accuracy score into 100. So why I'm multiplying it with 100? So that I will get 80 percentage, right? 0.8 I will get for sure. So into 100, if I zoom means 80 I will get. So simply I will just pass percentage in the last. So 80 percentage accuracy I am going to get. See, so the accuracy of my model is 80 percentage. So by using the confusion matrix itself, we can find the accuracy, but we have to do this calculation. To avoid that, I am using the default function. Okay. And then I'm multiplying it with 100. I'm saying this much accuracy I'm having in my data set. Okay. So now if I change the data set, okay, 25 percentage I have given for testing, right? If I given only 20 percentage for testing and 80 percentage for training, means again some percentage change will be there. Okay, you just try and change the value. Okay, you just try the random state. Well, the lab session I'm saying, I have given 0, right? You gave different value and check whether any change in the accuracy and whether you can able to achieve more than 80 percentage by changing what and all we can change and test. Random state you can change and test. Testing value you can change and test, and you can specify the random state in the logistic regression also. Here also you can give random state if you need. Otherwise I will mention. Sorry, just a minute. So this one is optional only. So random state is equal to some value you can give. I will mention it as optional. Understood? We can try it with different values. Random state we can give and not give, how it is coming. Testing we are reducing, training you are increasing, how our values predicting. Okay. Prediction is for testing value only. That 20 percentage, 25% data we have taken, right? For that only we are predicting, because that is the completely new value to our algorithm, right? Training value, 80% we already trained, so our algorithm knows that values. 20% we have not yet showed to our algorithm. It is completely new to our algorithm. So based on that new values, how it is predicting, that is what we have checked. So last step is, so 80 percentage it is predicting, right? So what I'm going to do is here predicting whether a new customer will buy the product or not based on the agent salary I'm going to create. So for that what I'm going to do is I'm going to get input from the user. Okay, this is not even in the data set. Completely I'm going to get new data from the user. So I'm going to get age and salary. So age is equal to like integer value only I need for both. So int of input of enter new customer age. Okay. Similarly salary. Salary is equal to int of input of enter new customer salary. Now whatever value I'm getting, it is separate variable only, right? So I have to convert it into data frame. Okay, then only I can pass it into transform I have to do. Then I have to predict. Then only based on the prediction I will say whether the customer will buy the product or not, right? So to convert these two values into a data frame, what I can do? So I will create one new customer, or I will give it like new customer is equal to, so if I give it in a double square bracket, okay, I can able to convert it into a data frame, right? nested list. Normally, if you are seeing it is a nested list, but if you are seeing it in logic of numpy and panda means it is a data frame, right? If you are, I am giving only one square bracket means it will become an array. Okay, so that is why I am giving like this. So I am passing the age value and then the salary value. Double square bracket means data frame, but here it is a nested list only. Okay, I am not converting into data frame like pd dot data frame. I am not converting, just combining the value. Okay, so that it will be easy for me to pass it into the new that transform. Here we have done the transform, right? See sc dot transform. Then after transforming, we have to predict it. So both the function I am going to use in the same line itself. Okay, and I will be getting result. So result is equal to model dot predict. Okay, so I'm going to predict what I'm going to predict sc dot transform. So sc what? Here I have created the variable name as sc, right? This object, that is what I'm giving as sc. If you have given different name means here also you have to change the name. So sc dot transform, and then I will pass the new customer information. Okay, so output I will be getting it as two value only. Either it will be 0 or it is going to be 1. Right. So for our understanding, I will print the result. Okay. Shall we check whether the customer will buy or not? Okay. Enter new customer age. So I am giving 27 as a age. And then new customer salary. What salary we can give? I am giving 60,000 the customer's salary. So it is saying 0. 0 means what? The customer will not buy the product. Okay, again I'm running this program. Okay, I'm giving different age. I'm giving 30. Okay, and I'm giving the salary is 1 lakh 10,000. 1 lakh I'm giving. Okay, let us check whether this particular customer will buy the product or not based on his age and salary. Okay, again it is coming 0. If you are giving with different values means at one point of time you will be getting 1. Okay, 1 if it is coming means we will say the customer will buy the product. Otherwise I will give different value and I will check. 26 I'm giving. Again I'm giving 1 lakh. Okay, again I'm giving getting 0. Okay, like that you pass different value at one point of time you may be getting one value. Otherwise, wait. Based on the predicted value I will take. Third value it is predicted as the customer will buy, right? So third value I will take. So white train extreme white train. What should be higher? A should be higher. Okay, 60 34,000 is there, right? Let me check that. Okay, see, it is saying that the customer will buy the product. Okay, so what we can do instead of seeing 1 0, we can create a if else statement, right? So if result is equal to 1, then what I can say? The customer will buy the product. Okay, else customer will not buy the product. or customer won't buy the product, anything you can give. Okay, once again I'm running and show it to you. So we have seen both the output also. Customer will buy also we have seen, customer will not buy, one example also we have seen. So you told to give 45, right? So 45 I'm giving, and salary as 30,000. Okay, 30,000, 30,000. Okay, so it is saying customer won't buy this product. It will change accordingly, it will change. If you want to see the customer will buy the output means, you can take these examples, predicted values is there, right? So from that you can give any one example and you can check whether same output is coming or different output is coming, that you can check. Okay, so no need of this line, right? I will just comment it. So we have what example we have, 64,000 and 34. Okay, see, customer will buy the product, like that you will be getting output. Yes. It can be in the last. I have given it here. If you want means you can put it in the last also. Okay. Uh, to put it in the last, it is up to us only. It is after checking the accuracy or increasing the accuracy also, we can predict. Okay. So I have put it in the last itself. Okay. Clear for all. Okay. So in today's lab session, what you are going to do is, uh, l- we have used the in previous class we have used one data set, right? Two data set actually. I have uploaded that questions also in the Vidya portal. Okay, I forgot to upload on Friday, Saturday. Okay, Sunday only I have uploaded, I think. Now you can go and check. So now we are having totally three data set we are having. Two is a older one with only hours and with sleeping hours is there, right? So for that particular data set, try to perform the logistic regression. Understood what I am trying to say? For this data set, that student sleeping time and the score, you try to perform the logistic regression method and say whether you are getting more accuracy or not, whether you are getting more accuracy or less accuracy. So that is going to be your today's practical. Okay, this also you try, whichever program I am doing, you just try it with the data set. I will be uploading the data set. Program I will not upload it as Jupyter file, because you will be running the same code. You just type and experiment on those code. Okay, change the values and try it by yourself. Okay, understood. You can do vice versa also. Okay, understood. Any doubt in this logistic regression model? Okay, if clear means I'm also happy. So day by day, a new algorithm will be coming and a new concept I will be explaining with new data set. So try to attend the class, try to practice all the algorithms then and there. Because based on yesterday's or previous class algorithm only, uh, today lab will be there. Okay, today I have taught logical regression. So based on previous data set, you have to perform logical regression. Tomorrow, if I am taking new algorithm, is based on that new algorithm, you have to perform uh, now with the new data set or existing data set, you have to do. Okay. So thank you all.